we use the kinematic data from the balance trials to calculate whole body center of mass. Now let's talk about the clinical significance of the center of mass. Center of mass is the average location of the body mass and is a unique point in the body around which its mass is evenly distributed. This means that the mass of the body above and below the center of mass are the same, and the mass of the body on the right and left sides of the center of mass are the same. We will discuss this in later unit, but the center of mass is also a point where the force of gravity acts through. When the adult is standing still in an anatomical position, the center of mass is located a few inches below the belly button. The center of mass location is slightly lower for females than in males. This is because females tend to have wider hips and narrower shoulders. The center of mass location in human body can change with body movement. For example, if you lift your right arm to the side, the whole body center of mass will move slightly upward and towards the right. The center of mass location can also be affected by body shape. Infants and children tend to have higher center of mass because their head is large relative to their body. As they grow, their center of mass will gradually get lower. A pattern of obesity in which the person accumulates fat in the belly area can also shift the center of mass forward. Similar shift in center of mass happens in pregnant women, which can make them easier to lose balance and fall. Also, carrying a heavy object can also shift the center of mass. Analyzing the center of mass location is important because the location and movement of the center of mass relative to the base of support affects stability of the individual. Base of support is the area within the lines of connecting the outer perimeter of each of the points of support. In the picture below, there's a person with a walker and another person with a cane. The base of support of these individuals without the walker or the cane is limited to the area within the perimeter of their feet. You can see that the use of walker or cane can significantly increase the individual's base of support. In order for us to remain in balance, the location of the center of mass must be located above the base of support. As soon as the center of mass moves outside of the base of support, we will lose balance. This is why the location and movement of the center of mass is important in maintaining stability. The closer the center of mass is to the outer edge of the base of support, the closer you are to losing stability. Now, in a single leg stance, the body's center of mass tends to move more in forward-backward direction rather than in side-to-side direction. This is because our feet are longer than wider, and therefore the center of mass can move more in the anterior-posterior direction than in side-to-side direction before we lose balance. Postural control refers to our ability to control body center of mass in order to maintain, achieve, and restore balance. Our body uses three feedback systems in order to control our posture. The first system is the vestibular system. Vestibular system is located in the inner ear and is responsible for detecting orientation of the head relative to gravity and head's linear movement. The second system is the visual feedback system. The vision helps us to balance by allowing us to detect orientation of the body relative to the surrounding. The third is the proprioceptive feedback. Proprioceptors are sensory receptors that are found in soft tissue, such as muscles, ligaments, tendons, and joint capsule. These receptors senses stretching of the soft tissue and detects body orientation relative to the standing surface. For example, the forward sway of the body will cause the Achilles tendon to stretch, which allows the central nervous system to know that we are leaning forward. The central nervous system integrates information from all three feedback systems to control posture. This means that removal of one or more feedback systems will likely compromise postural control. When the central nervous system detects the need to adjust posture, it sends signal to the muscles. If the central nervous system only needs a small adjustment, the muscles around the ankles are stimulated to control the sway. We call this an ankle strategy. If the central nervous system needs a larger adjustment, the muscles around the hips will be activated to maintain balance. We call this a hip strategy. If the adjustment required is too much to be handled by the ankle or hip strategies, the central nervous system will send signal to initiate step strategy. In step strategy, the person will take a step to widen their base of support. With your understanding of center of mass and postural stability, you can begin to identify potential causes of fall, which is a big issue in elderly population. Some of the causes include vestibular disorder and visual impairment that affects the feedback systems. If the body cannot detect the loss of stability, the body cannot make adjustment. Dizziness is a common cause of fall among elderly. Being dizzy makes it difficult to detect loss of stability. Additionally, slow reaction time and weak muscles can contribute to fall. Muscle strength and reaction time is important in initiating ankle, hip, or step strategy. At last, having an unsafe environment with lots of tripping hazards can cause a person to trip and cause their center of mass to move outside of the base of support. On the other hand, we can also consider strategies to prevent fall based on what we learned. Medications to control dizziness or vestibular problems and corrective lens can improve the feedback to the central nervous system. Exercising to increase muscle strength and reaction time may make them more likely to be able to break the fall. As mentioned earlier, use of cane or walker can improve stability by increasing the base of support. Making the safe home environment is also critical.